Hello everyone. Today in the subject of industrial biotechnology we are going to study about bioethics. So the main objective of this topic is to give you an introduction about bioethics, why they are there, what are their main objectives of concern and how they play a major role. The outcome will be you will be able to understand the policies and other influencing factors of bioethics. So bioethics they do play a major role whenever it comes to the work scenarios of doctors and scientists and industry personnel. Because most of the time, the scientific community or the people who are working in the industry, they are so much inclined towards the development of medicines and development of new solutions that they start to avoid uh, the humane factor of many things. So that is why this very new paradigm of bioethics have taken place. Okay, in order to produce justice and virtue, and the working scenario should be in a very particular order that any harmful effects or any disturbances when it comes to humans can be created by sciences. So these things they do affect a lot of experimentation procedures, like it has already banned human cloning. Otherwise, scientists would have been practicing these things on humans also. So many things when it comes to industry also, the things should be produced in a very humane manner, right? So you should not that much be scientifically be indulged in the scenario that you start avoiding the humanity. So bioethics and biotechnology. Modern biotechnology arises most of the issues facing science and technology today. Right. So why modern biotechnology? Because biotechnology is a combination of biology and technology that is exploited for the benefits of human these days. Okay. These include rapid research and development, major potential for improving the human condition, misunderstanding and fear on the part of the public, and conflict of interest as the nature of funding the research changes. So, on the one hand, the scientific community and the industry they are totally working on the betterment of human society, right? They are always providing necessary steps that should be taken, and what how new medications should be developed in order to produce uh, good health facilities for human beings. But yeah, it has readily improved our medical facilities, our crops also, and many other things. But that also leads to some sort of fear and misunderstanding among the public also. They because the most important factor is that the scientific community does not readily deal with the general public, and their research is most of the time is not using the general public terms also. Right. So it is very much important that people should be made aware of what the current scenario of research is going on. Okay, what are the things essentially that are playing role for the betterment of their own lives in the coming future? What type of new medications are being involved, and without any cost of on cost of any experimentation that are not accepted by the public or by the society. Biotechnology's potential for good must be uh, of its seen in lights of its potential harm. So everything has its two basic scenarios, right? So whenever you are working on these things and whenever you are providing solutions for these things, you must necessarily involve the potential of good and potential of harm. Right? Most of the time, individuals who are carrying on to these things, they must understand that there are two faces on the phone. Okay, it can do a very good job also when it comes to the use of biotechnology in industry, but it can readily also have some drawbacks or side effects. The society's ingenuity in undertaking robust ethical analysis of the many issues raised and developing guidelines, however, lags far behind the ingenuity of scientists and investors in moving the field forward and developing new and powerful technologies and products. The main important problem is that uh, the society's ethical concerns are there, right? And on the other hand, that requires developing new guidelines. But all these scenarios they do lag behind. As a result, that scientists and investors they want something else in the scenario that is going on. Okay, they want something new. They want something uh, indifferent that should take place, and there should be a tremendous growth in the field of industry and new medicines. And every time we should able to evolve and make new vaccines and new medicines. So the scientists and investors they do not think in that concern that what effect these research are going to have, although they are going to have positive effects, but in the long term it will have some sort of negative effect on the society. So it is very important for that community, for that very uh, level of understanding to develop in order to support those issues that can arise in between the scientific community or industrial community and public, right? So robust ethical analysis is required, and it requires new guidelines so that this gap in between these two communities can be bridged readily, and people should be able to understand all these scenarios in details. Both bioethics and biotechnologies have ancient and modern basis. In the West, bioethics goes back some 2,500 years to the time of Hippocrates, right? So, biotechnology, humans have always been innovative. They have been developing new techniques since very ancient times, and they always have been trying to produce new chemistries, new chemicals, new medicines, and they were always searching and or want to develop new techniques that can be used for the benefits of humanity. Elsewhere, bioethical tradition goes back even further. Biotechnology, on the other hand, uh, is as old as human civilization, readily. And when the humans started to live a settled life, everything it changed its course, and things come under the uh, banner of new development. And people they started trading with each other. People they also started to work together and learn new techniques from everyone. And the people who were there, they were trading, so they were sharing technologies and techniques all over the places. Both, however, have distinctly recognizable modern manifestations, beginning roughly in the 1960s. So, when the modern technology came into existence, everything has transformed itself from ancient to modern. But somewhere the principles are still the very same. So, in this lecture, what we are going to introduce major issues in today's bioethics and biotechnology. In the process, highlights how the two have, to some extent, influenced each other's development in the past half century. So, bioethics and biotechnology are always coming hand to hand, right? So, whether it comes to cloning of humans, whether it comes to the developing of new vaccine or diabetes serum or the liquid that is required for the treatment of diabetes, right? So, when the industry started producing insulin on a large scale, so all these things they had readily produced a lot of scenarios. Okay, all these things do affect them on a major basis. And since half a century, everything is going on and on and on. And these issues are always arising up. These issues are always being there. So most of the time, you always have to think that these things are not modern. Okay, there have been always a conflict of interest in between the communities that support scientific and logical reasoning and the communities that don't support this scientific logical reasoning. So you have to strike a perfect balance that most of the time these people they do not get affected because of these things. 4000 BC dairy farming by Egyptians who also used yeast for bread and wine. 3000 BC Peruvians select breeding potatoes. Okay, 2000 BC Egyptians, Sumerians, and Chinese developed fermentation, brewing, and cheese making. 500 BC people in the Mediterranean developed marinating and European flavors and preserved food. See, these things are not new. They have been already there since the very early time, and people were already sharing their technology and their techniques as they were sharing their trade. 500, 1500 BC, sauerkraut and yogurt from acidic cooking, examples for using bacteria for human needs. Aztecs make cakes from spirulina algae. 1861, Louis Pasteur developed techniques of pasteurization, and 1879, William Bale developed first experimental hybrid corn. So now here you must understand how the things are playing role, and humans have been using biotechnology since a very ancient time. This is not a modern science. This is not a new thing. It has already been there since a very long time. The word biotechnology derives from three ancient Greek words: bios meaning life, techos meaning tool, and logos meaning study or word or essence. Thus, extracted etymologically, uh, it becomes the study of tools from living things. The term biotechnology can be traced to 1917, when it was used to refer to a large scale production of material from microbes grown in vats. So, biotechnology has already been there, and biotechnology has already been in the use since a very early beginning of time and early onset of human settlements. So, every time this was being shown by humans that level of skill they had, and they had been working really hard, and because of their early work we have been able to reach to this level today. During the First World War, it referred to the use of industrial fermentation to produce industrial feedstock such as acetone, which was used to make cordite and explosive. Biotechnology will play a bigger role in our lives. There is little doubt that biotechnology will play a bigger role in our lives in this century. It is already a market worth approximately uh, 50 billion US dollars. The important use of modern biotechnology can be summarized in five F's. So, what are those five F's? And internationally, this market is of $50 billion, and it is a huge market, right? So, the first F is food. About half of the soybeans and one third of the corn grown in United States in 1999 contains foreign genes. So, not only when it comes to medicine, scientists are constantly working on improving the crops also. Okay, making them much more less likely to take fertilizers and metals, making them much more disease resistant, improving their variety. Okay, making their size large. So every time the scientists are working constantly in order to improve the crops. Fuel. Different types of fuel can be made using biotechnology techniques. For example, yeast ferment corn starch to yield ethanol. Okay, especially the species of yeast that is used is Saccharomyces cerevisiae. Bacteria decompose sludge, manure, or landfill waste to produce methane, and firewood heats home. Feedstock. Instead of petroleum, biorenewable materials such as starch from corn or whey from cheese making can be used to make plastics. So plastics these days are being produced from cheese making and corn, and it is much more reliable and much more environment friendly. Fiber, a new example of industrial biotechnology for fiber is biopulping, using a fungus to convert wood chips into paper pulp while reducing energy and while reducing energy use and pollutants. Other fibers from plant and animals include cotton, wool, silk, linen, leather, umber, and paper. So every time new techniques are being worked upon and new scenarios are being developed so that these things they can readily be used. Pharmaceuticals, vaccines, antibiotics, and other therapeutic agents produced by microbes, plants, or animals fall under this category. Newer pharmaceuticals will increasingly come to depend on modern biotechnology techniques. Okay, so vaccines and antibiotics and other therapeutic agents they are produced by microbes readily, and plants and animals fall under this category. So pharmaceuticals, more and more techniques are being used for recombinant DNA technology. Okay, and large scale production are being readily exploited by the E. coli bacteria. Although its genome has been clearly understood and it has been read every gene by the scientists, now that very organism can be exploited for the benefit of humans. Okay, newer pharmaceuticals will increasingly come to depend on modern biotechnology techniques, and it is very true in nature. Like every time, whatever the technology, or whatever the antibiotic, or whatever the vaccine is coming into the role play, it has been developed by the combination of biotechnology and other techniques. So it is a major portion of human development that will launch us to a new future. The genetic revolution and human health until quite recently, our knowledge of disease at molecular level has been quite limited. However, exploding knowledge in genetics over the past decade has begun to change the picture. Right. So when the DNA was discovered, and when humans they start really started to realize the potential of molecular biology, and genetics revolution really took place, and all the things they come into this role. Now the scientists have realized and they have noticed what are the levels of development that are extremely essential. So this knowledge has readily inculcated a lot in the picture that is essentially needed for the development of our agriculture and food quality and life quality. Interestingly, uh, what is emerging is that while our genes may have loaded the gun, environmental factors pull the trigger. Okay, so every time now what we are doing these days, although we have realized that all the life has evolved from a universal common ancestor, Luca, right? In that scenario, everything is going on, and we all took different branches and different um, modes of development. And as a result of that, because of these things, everything has been changed. Okay, and everything is playing a major role in the scenario. But because of that only, uh, scientists have able to improve the variety. Now they can transfer the genes in between the species, like copies in between uh, laptops and computers. They can get copied from one computer to another. So it is very essential. Genetics, genetic knowledge can be used to prevent conception and to screen, diagnose, treat, and prevent manifestations of diseases in those who have genetic susceptibility. Now we can, because of these things, we can readily predict that a very particular individual will have this disease likely in future. Okay, and as a result of that, scientists have been naturally molecular scientists, and genome analysis has led us towards such particular type of state that we are very much now being able to understand the links that are essentially important for the development of new varieties and for the treatment of the disease that might cause some harmful effect on humans in the near future. So we can readily take preventive measures. So here in this image, what you can see, bioethics has been linked with several different aspects. Okay, and what are those things? Genetically modified organisms or GMO. Although they caused a lot of issues in the recent past, but it has been proven with time the scientists have been able to uh, design this species in a newer format and improve its genetic quality in order to increase the yield of the crops, also in order to enhance the breed of animals. Okay, biotechnology and nanotechnology that has reached to a very small scale, and it has leveled up and opened a new aspect of technology where the things can be built on very small scale or nano scale. And end of life can readily be explained that what are the genes that are essentially important and what are the genes that are essentially needed for the development of the species and what will be the lifespan of that very particular species. Organ trafficking is also a very huge drawback these days. Okay, so it should be dealt with bioethics, and more and more concern should be there. So, how to support humans and how to support new things, protecting the integrity of participants in therapeutic trials. So, we must readily decide the development of new technologies and implementation of new techniques should not be on the basis of human. Okay, environmental ethics. So, what are the things that are being developed slowly and slowly? Okay, our environment should not be harmed. It should be readily protected, and our biodiversity should also be a huge level of concern when these things are being developed. right? Biodiversity comes all the plants and animals, they should not be disturbed in their natural habitat. Human cloning was a very big issue that has been banned because all the individuals from different religions, they took place in that meeting, religious heads, and they decided that we should not play God, right? But the scientists were also claiming that if we will not play God, then who else will? So, human is the creation of God, and it should be left like that only. Assisted procreation, okay, IVF and all those things are readily seen. Okay, these technology now we are creating human embryos artificially. So in near future, it will open a new dimension, access to medicines and healthcare devices. Now it is becoming readily more and more easier uh, to get the access uh, of new medicines and newer healthcare devices. So this revolution has fueled by the developments in information and technology will have a profound impact on humanity in this new century. It will change our understanding of ourselves and of the etiology, manifestation, progression, and management of physical and mental diseases. So, every time new technology is affecting us, okay, and we want that when the humanity is going to enter in the new century, it will be equipped with all the tools and techniques that are essentially required to improve this species and improve the illness. And we can also edit the genes in humans in order to avoid all these mental diseases and physical diseases and all the chances of getting any sort of disease. The new era will witness a profound change in traditional healthcare delivery and public health, and in pharmaceutical and agriculture industry. It is very important that because of those things only, we have been readily able to restart our agriculture system, and we have certainly modified our healthcare system. So it is also benefiting the general public widely. The revolution will also change the traditional boundaries between medical disciplines. So, in the recent past year, although our medicine has developed a lot, our techniques have developed a lot, but the main scenario has been the same. Uh, our study on virology was lacking, and it has resulted a major pandemic outbreak of coronavirus. So it has also exposed a major chink in the armor that although we claim to be a lot more developed, a lot more advanced, and because of these things, it has been included that we have to improve everything and we have to see that thing uh, readily inculcates in the development of the medicine when it comes to viral diseases. It will force us to reassess the contribution of environmental factors, including chemical, infectious, physical, social, psychological, and nutritional factors, to public and individual health. So, scientists and doctors are readily working in combination with industry to improve the disease conditions, to improve the medications, and to find out a quick solution to the viral diseases. Although our medical field is still lacking in the diseases caused by viruses, okay, and scientists and doctors, they readily treat the symptoms. They don't treat the disease. They only treat the symptoms. So we need to change our gear, and we need to have and develop new technology. And because of these things, everything will be of newer aspect, right? So it will give us a new tool to manipulate these environmental factors in relation to individual genetic endowment. thereby personalizing prevention and therapy in a way not previously possible. This will include the management not only of acute chronic diseases but also of chronic disease such as Alzheimer disease, cancer, and diseases of cardiovascular system. So they all need a lot of development, a lot of study. Developing ethical guidelines for biotechnology. Important modern issues to consider: the rapid place of research and development in agricultural biotechnology, in unraveling the human genome. It was a huge achievement after the landing on the moon. In cloning and stem cell technology, and in organ transplantation, has made it crucial to study the potential impact of these technologies on society and to uh, ethical develop ethical guiding principles in light of potential social dislocations that might arise from the genetics revolution. Organizations have developed ethical guidelines for biotechnology. These guidelines attempt to capture the consensus view of value in society and trace the implications of these values for human action. So, although the technology is really developing rapidly and things are changing rapidly, and scientists have been able to transform many things that earlier were not possible, and even the medical science is also making huge leaps and bounds. And but still, when it comes to the study of virus, we still need a lot of development, and that we have realized in this current scenario. But on the other hand, our science and technology is progressing a lot, and it has made a significant progress. And still, the guidelines are needed for the biotechnology, so that everything should come under one banner. Okay, ethical guidelines are being nowadays they are being much more thoroughly investigated, and these things are much thoroughly being discussed. These changes, while they may have an immediately beneficial effect on the economy and in generating discoveries and intellectual property, do have the potential for conflicting of interest. Right. So, uh, on the other hand, they might be beneficial for the economy. They might be generating a lot of new discoveries and IPRs, but they can readily cause a lot of conflict with the interest of the people also, because most of the time a committee should be formed that can readily and easily elaborate the conditions, the scientific research in layman's language to the common people, because most of the time the individuals who are very common, they are very less likely to understand the potentials, and they are very less likely to understand the conflicts. Okay, so the scientific community should be brought in contact with a lot of uh, public interest. Okay, they should be brought in contact, because scientists they don't want to deal with public, and public they do not want to deal with the scientific community, and especially the scientific community who is uh, leading the role and leading the things from the forefront. They are not very good at dealing with the public and dealing with the politics. Okay, they always want to be left alone with their research and their things. But the scenario has to be changed, and every time scientists have to make sure that his or her research is understood well in the common language. Right? Researchers caring for patients may have a stake in the products or technologies being tested. Every time, every medicine and technology has to be tested on human after being run on several trials on experimental animals. Many academics own shares in biotechnology companies or sit on their boards. The same applies to those entrusted with developing science policy. So, science policy also needs some sort of upgradation because most of the time the bureaucrats who are working on these policies, they don't have any scientific knowledge, they don't have a very good scientific exposure. So they develop policies. They uh, somewhat is much more conflicting with the scientist or with the interest of the science, right? So we do need representatives in the governments, and we do need uh, representatives in the technology, in the bureaucratic society, who can readily understand the work of scientists and translate the language in an easy form to the people. Some people feel that patients' rights and interests may be sacrificed in the rush to obtain intellectual property. Blood sample taken for one test may subsequently used to obtain DNA for other purposes not consented by the patient. So consent of the patient is also readily very important in nature. So it should not be done, and it should be observed as patients' rights and interests. And it should never be sacrificed for the sake of the science and biotechnology or bioethics. Right. Pharmaceutical companies are rapidly accumulating genetic data and DNA specimens to study the genetic basis for individual patients, responses to drugs, both old and new. Researchers hype the potential of their discoveries so far as to inflate share valuations of companies uh, in which they have stakes. Public trust of biotechnology. This is very important uh, in order to make public to understand the role of biotechnology and how this technology does play a major role for the interest of public. Engaging the public, a number of recent events have pitted members of the public and some special interest groups against major biotechnology companies. In Europe, this emerged against the background of mad cow disease, where the public felt let down by regulators who failed to identify the connection between variant of Jacob's disease and the consumption of beef. So in Europe, it led to a major clash between the scientific community, government, and public. So that scientists were not able to assess the situation, and government were not able to play a vital role. GM foods or genetically modified foods were decreed by prominent people like Prince Charles and banned from being served in the British Houses of Parliament. Okay, demonstration against farmers growing experimental fields and supermarkets carrying genetically modified food have been a common uh, in West. So and have fueled many controversies. So these controversies started to appear because lack of education and somewhere the scientific community has to come in the forefront in order to explain the things in much more simpler manner to the layman or to the individuals who do not have any sort of scientific knowledge or scientific understanding. The rapid pace of development in science and technology, ethical guidelines cannot be developed quickly enough to keep up. The lack of public trust in scientists, corporations, and regulators, partly due to the failure to safeguard our public against infected blood, and more recently against mad cow disease, and also more recently coronavirus disease in Europe. The poor ability of institutions to educate the public on complex scientific issues without uh, obfuscating and or patronizing the public, increasing demarcations and demands for accountability and transparency. Rapid increase in availability of information, especially through the internet. So things have started to change a lot these days. Development of technology for which there is a little precedent in its own terms and uh, in terms of its ethical use. The lack of coherence uh, within the bioethical establishment itself, in terms of having strong foundational values accepted by all, the technical complexity of the issues, the appearance of technology that is seen as unnatural or brought about by playing God, globalization of economies in which policy decisions in one country have implications for many other countries, vocal, well organized protest groups, and increasing public recognition of the impact of our actions on the environment, and enhanced appreciation of humankind existing with other creatures in one biosphere. So, general public needs to develop a lot of understanding. A lot of exposure is needed for the public, and because of these things, things they do have started to change rapidly, and because of this, new understanding is developing, and also because of everyone is having access to the information because of internet. Now people are having a lot of understanding about the things and pros and cons that are related with those things. So, five social ethical issues in industrial biotechnology. These cases indicate some common uh, societal themes that are brought forward by innovations in industrial biotechnology. As stated above, these are sustainability, naturalness, risk management, innovation trajectories, economic justice. These themes are interesting and relevant to the advancement of industrial biotechnology because different perspectives exist on how we should deal with them. These perspectives can be related to different values, assumptions, and beliefs among different actors has been described below. Sustainability, whether an application of industrial biotechnology can be considered sustainable, can be determined by measuring the quantifiable impact of that application, such as contribution to CO2 reduction, uses of resources such as water, release of toxic substances, and so forth. However, as emerges from the cases discussed above, other non-quantifiable factors may also play a role in assessing sustainability. These factors may be difficult to quantify because they are very complex and surrounded by many uncertainties and differences in perspectives. For instance, the effect on social well-being of people working in a bio-based value chains, such as for biofuels. Although efforts are ongoing to measure this well-being, is notorious hard to define because of many different ways to optionalize it. Nevertheless, literature on assessment of social sustainability for bioeconomy is becoming more frequent, and several social issues like employment, working conditions, labor, uh, right gender equality, social development, and for food security have been discussed. The advancement of industrial biotechnology has been uh, uh, has been recently playing a role, right? So, sustainability assessment is also very important. Okay, so whenever scientific community is there, one must understand that how the things are changing and how the things needed to be observed properly. Sustainability is not something that can be directly witnessed. Potential consumers and society at large needed need reliable indicators to show them which products are sustainable and which are not. Such indicators will only be considered reliable when people feel that they reflect the concerns they have about sustainability and hence serve the wider public good and not a particular interest. When designing indicators for sustainability assessment of products from industrial biotechnology, it is important to acknowledge the different views on sustainability. These different views will be further uh, explicated in the following sub-themes, which all relate to the overarching themes of sustainability. Responsible research and innovation for industrial biotechnology is very important to support uh, society. Intricate technological trajectories are very important. The approach responsible uh, research and innovation (RRI) have been proposed. RRI has been defined as a transparent, interactive process by which these things and innovators become mutually responsive to each other with a view of ethically accepting sustainability and uh, desirability, embedding of scientific and technological advancement in the society. So this approach is changing a lot, and it has inculcated a lot of issues, and that has been resorted on. Inclusion implies that a wide range of people and perspective is taken into account when developing a new technology. In the bio-based economy, inclusion already takes place in many shapes, such as for certification and monitoring of sustainable biomass. There is an ongoing international debate on the norms of sustainable biomass as well as on the quality level monitoring of these norms. A wide variety of actors takes place in these debates, such as NGOs, companies, and governmental organizations. In views are incorporated in schemes for certification and monitoring of sustainability. So the criteria by which sustainability is determined are hence done in an inclusive practitionary manner. Okay, so these days things are changing and scientific community are becoming more and more aware. So the conclusion is that industrial biotechnology carries the promises of a sustainable solution based on natural resources. However, some issues invoke uh, social criticism, showing that different actors have different perspectives on salient issues. These issues include sustainability, naturalness, risk management, innovation trajectories, and economic justice. To achieve socially robust innovation, innovators can learn from actors who have been a different view on a specific application. The framework of responsible research and innovation offers guidelines to organize such learning. So these guidelines are based on the principles of anticipation, incursion, reflexibility, and responsiveness. The outcome of such learning process might be that an innovation trajectory is adapted, or at minimum that the innovator are aware of the possible objections to their innovation and widen their understanding of their motivation for pursuing that innovation. So these are the MCQs. IPR is a process which protects the use of information and commercial value. Which of the following is included in geographical indicators of good? All the above. Foodstuff, manufactured, handicraft. Which of the following is covered by the term intellectual property right? All the above. Copyrights, known how trade dress. Which of the following can be patented? Machine process, composition of matter, or all of the above? All of the above. What is a trademark? Is capable of distinguishing the goods or services of one person from those of others, may include shapes or goods or combination of colors, and is represented graphically. Which of the following is symbol of Maharaja Air India is trademark? In the design, which of the following design is not included? Okay. A composition lines or colors. Which agreement is uh, enforceable by law? Valid agreement. These are the references from where we have taken the content, and thank you very much for listening to us.